Hello dear students of +1 medical, non-medical, respected teachers and dear friends. In this video I am going to discuss about wave motion, how waves can be explained graphically and what is the expression for velocity of a wave. So let us start. First of all, what do you mean by a wave? So wave is a kind of disturbance that travels onwards due to repeated periodic vibrations of the particles of the medium about their mean positions, and the energy is being handed over from particle to particle without their actual movement. So when a wave propagates through a medium, this is known as wave motion. So wave propagation through a medium depends upon two main properties of the medium. Number one is property of inertia. Number two, property of volume elasticity. For example, when we throw a stone on the surface of still water in a pool, then at the point of disturbance where stone has been thrown, particle gets disturbed, moves downward from its mean position to extreme position. Now, due to property of inertia, every particle tends to remain in its own state, own position. So, when it moves down, its velocity decreases and it stops for a moment for at the down extreme position. Then comes back due to property of inertia of rest. Then it gains speed, gains velocity. As a result, it overshoots the mean position upward due to inertia, property of inertia again. Now, when it moves upward from the mean position, then due to gravity, its velocity decreases and stops for a moment and then comes back. As a result, this disturbed particle starts vibrating up and down simple harmonically about its mean position, and the energy is being handed over from particle to particle. That's why when we throw a stone on the surface of still water, ripples are formed on the surface of water. Having circular ripples are formed of increasing radii. And if we put some paper on surface of disturbed water, that is on the surface where ripple has been formed, you will see that paper or boat of paper starts moving up and down. It doesn't move in any direction. It proves that it is only the disturbance that travels, not the medium itself. So disturbance travels through a medium without its actual movement. That disturbance is called a wave, and when it propagates through a medium, it is called a wave motion. Then, types of waves. The waves, there are two types mainly. Transverse waves. Transverse waves are those waves in which the particles of the medium vibrate about their mean positions in a direction perpendicular to the direction of propagation of the wave. Suppose wave is propagating from left to right. So each and every particle medium will start vibrating about its mean position up and down like this. Energy is being handed over from particle to particle. So for example, waves produced in a stretched string, all electromagnetic waves, waves produced on the surface of water, that is ripples, they are also transverse in nature on the surface of water. So these are the examples of transverse waves which travel in the form of crests and troughs. Then longitudinal waves, those waves in which the particles vibrate about their mean positions along the direction of propagation of the wave. So a wave is traveling from left to right, so particles vibrate about the mean position like this. For example, sound wave is an example of longitudinal wave. Now, how we can represent transverse and longitudinal waves graphically? So to understand the formation of crest troughs or longitudinal wave travel in the form of compressions and rarefactions. So formation of compression and rarefaction. So we have to draw graphical representation. So to understand the formation of transverse waves, suppose wave travels from left to right along x-axis. Now we consider 5 particles only. Particle 1, 2, 3, 4, 5. 5 particles at equal distances from each other, and the distances are such that during the time the previous particle completes 1/4 vibration, disturbance reaches to the next. When next completes 1/4 vibration, disturbance reaches to the next. So let t is the time period of vibration of each particle. Then what happens at t is equal to 0? Suppose particle 1, 2, 3, 4, 5 all at rest initially. At t is equal to 0, particle 1, number 1 is disturbed. So it starts moving down. But particle 2, 3, 4, 5 are at rest. Now after t is equal to t by 4, 1/4 of time period, particle 1 will reach to the lower extreme. So this is the upper lower extreme of every, this is the mean position. So upper lower extreme position shown by dotted lines. So particle 1 completes 1/4 of vibration, reaches to the lower extreme. Particle number 2 just disturbed as per our assumption, as distance is such that 3, 4, 5 are at rest. At t is equal to t by 2, particle comes back to the mean position, and it means it completes half vibration. Particle 2 reaches to the lower extreme, particle 3 just gets disturbed, 4, 5 are still at rest. At t is equal to 3t by 4, particle 1 reaches to the upper extreme. Now note, at every extreme position, lower extreme or upper extreme, direction of motion is reversed. That's why it starts vibrating about its mean position. So it is to upper extreme at t is equal to 3 t by 4. So particle 2 reaches to the mean position, direction remains same. Particle 3 reaches to lower extreme position, direction is reversed. Particle 4 just gets disturbed, and particle 5 is still sleeping. At t is equal to t, particle 1 reaches to the mean position again. From where it starts, it means particle 1 has completed one complete vibration during one time period. Particle 2 reaches to the upper extreme. It means particle 2 has completed 3/4 of vibration. Particle 3 reaches the mean position. It means particle 3 has completed half vibration. Particle 4 reaches to the lower extreme. It means particle 4 completes 1/4 vibration, and particle 5 is just disturbed. So this process continues. So I have taken the just example of 5 particles. There may be a number of particles. So if we join disturbed particles by smooth curve, you'll get curves like this, at t is equal to 3t by 4, at t is equal to t. So this is how wave propagates through a medium. Wave advances through a medium. Only 1/4 of trough is formed. One trough is formed. Half crest and one trough is formed. One crest, one trough is formed during one time period t. So this is called crest, this is called trough. It means transverse waves travel in the form of crests and troughs like this. And distance between two consecutive crests or consecutive troughs, or distance covered by one crest and one trough, is called one wavelength. So one wave, wavelength of distance covered by one wave means one crest and one trough is called one wavelength. Now similarly, formation of longitudinal waves. Again, we consider 5 particles. This is such that during the time previous particle completes 1/4 vibration, disturbance reaches to the next. T time period of vibration of each particle, particles are at equal distances. So, but in this case, particle will vibrate about their mean positions in the direction of propagation of wave. So, wave is propagated from left to right. So, here this O dark line show the mean position of particles 1, 2, 3, 4, 5. This is left and right extreme positions shown by dotted lines. Now, what happens at t is equal to 0? Suppose particle 1 is just disturbed toward the right. 2, 3, 4, 5 are at rest. At t is equal to t by 4. Particle 1 reaches to the right extreme. Direction is reversed. 2 is just disturbed. 3, 4, 5 are at still rest. At t is equal to t by 2. Particle 1 reaches to the mean position. Particle 2 reaches to the right extreme. Direction reversed. Particle 3 just disturbed. 4, 5 are still at rest. At t is equal to 3t by 4. Particle 1 reaches to the left extreme, means completes 3/4 of vibration. Particle 2 reaches to mean position, completes half vibration. Particle 3 reaches to right extreme, means 1/4 vibration. Particle 4 is just disturbed, 5 is still sleeping. At t is equal to t, particle 1 completes 1 vibration. Particle 2 3/4 vibration. Particle 3 half vibration. Particle 4 1/4 vibration. Particle 5 is just disturbed. At t is equal to 5t by 4, what happens? Particle 1 reaches to the right extreme again. Particle 2 to the mean position, completes 1 vibration. Particle 3 left extreme. Particle 4 mean position. Particle 5 right extreme. So all the 5 particles have been disturbed. So from this, if we again join these arrows, particle position of particles and the arrows with by smooth curve, we get a curve like this, like this, like this, like this, and like this. This is how wave propagates, longitudinal wave propagates through a medium. And we can see distance between first, second, third particle is less than their normal distances. But distance 3, 4 and 4, 5 particles is more than their normal distances in equilibrium. So it means this region is known as region of compression and this is known as region of rarefactions. It means longitudinal waves travel in the form of compressions and rarefactions. So compressions, rarefaction, compression, rarefaction, compression, rarefaction. So again, distance between two consecutive compressions or two consecutive rarefactions or between rarefaction and compression is known as one wavelength. So this is how transverse waves and longitudinal waves travel through a medium. Now, what is the relation for frequency, wavelength and wave velocity? General expression for any kind of wave. As we know that, suppose v is the velocity of the wave. No, here velocity, wave velocity and particle velocity are different. Particle velocity will be the velocity of particle vibrating about its mean position, which will be maximum at the mean position, minimum at the extreme position. It changes. But v is the wave velocity, the velocity with which wave advances through a medium, left to right. So then by definition, velocity must be equal to distance traveled over time taken. So during one time period t, distance traveled is one wavelength. So v is equal to lambda upon t, or v is equal to nu lambda, because 1 by t is equal to nu, frequency of wave. So v is equal to nu lambda is a fundamental equation of wave, and this equation is true for all types of waves, whether it's longitudinal or transverse waves. And if we multiply by 2 pi or divide by 2 pi, so we have v is equal to 2 pi nu lambda upon 2 pi, or it will be v is equal to omega upon k. So because 2 pi nu is called omega, angular frequency, and 2 pi lambda is called k, is called propagation constant of the wave. Propagation constant of the wave, and omega is called angular frequency. So this is all about what is wave, what is wave motion, what are types of waves, the examples, and how we can draw longitudinal as well as transverse waves graphically, and what is the wavelength, frequency, and wave velocity, and what is the relation between them. So this is all about these wave motion. In the next video I will discuss factors upon which velocity of wave depends, and expression of our velocity of wave for in air as well as in a medium. Till then, stay tuned, all the best, be happy, good luck.